To introduce our speaker tonight, we have Eric Anderson. Eric has been involved in programming, and he will take care of the
Thanks, Kent.
the introduction. Thank you.
You are a hardy crew. I'm so glad you made it through, and I think it's going to be worthwhile for you this evening. You may know we've been trying to run this program this year with kind of a theme to it, and that has been how humans are influencing the ecosystems of the planet Earth, and specifically the members of those ecosystems and the functioning of those ecosystems. So tonight we're looking at a very interesting member of the Great Plains ecosystem, which is this little, where'd it go? The swift fox, which, how many people have seen a swift fox in your life? You may not have noticed them because they're awfully small. They're about the size of a large cat. And they're also inhabitants of the Great Plains and are associated with prairie dog towns. And if you know anything about prairie dog towns, the physical extent of prairie dog towns has been reduced by some 95%. So it's really cut down on the available area for these foxes. So they're in trouble in their ecosystems, but they play a very important role. Tonight our speaker, Kara White, who is a graduate student at the University of Wisconsin, Stevens Point, is going to talk about what she's discovered about these animals. Not much has been studied about them, and so she's trying to get an insight as to what makes them tick, what makes them do what they do, and how we as humans are impacting them both positively and negatively. So Kara hails originally from Maine. I knew her when I was still teaching at the university as an undergraduate student. She was one of my advisees, and now she's moved into the realm of graduate student. All I can tell you about her is this: I've never had a more mature, more insightful, more driven student that I've had the privilege of being an advisor to than Kara. So tonight I think you'll get a little insight into some of that as she does her presentation tonight. And you didn't come here to listen to me, you came here to listen to Kara. So Kara, please take it away.
You are still my advisor. I'm still your advisor. So thank you.
Turn on your mic.
Oh, how do I do that?
It's the side.
I'll let you do it. On? Button that says on.
These things are, it's this side.
So while they were doing this, I was talking to one of my graduate advisors on the phone, so I missed the next talk. But anyway, thank you all for bringing the weather and coming out. So today I'm going to tell you a little bit about my experiences on the Great Plains working with swift fox. And so now, most of us outside of this room, and most of us have heard these tropes, but those of us not here tonight tend to believe these things we hear about the Great Plains, so there's nothing to do there. It's nothing but flyover country, and it's just flat and boring. And so tonight I'm going to hopefully try and change the perspective on that. And so these side notes, these photos are the new Nebraska state campaign to tourism. Pretty clever. Okay, so what is the Great Plains? So the Great Plains is characterized by these grasslands, and on the east here you have these tall grasslands. In the middle you have this mixed grassland system, and on the far west you have the short grass prairie region. And so this is where I'm going to be focusing most of my talk tonight, is on the short grass prairie ecosystem. And so, the shortgrass prairies is a host to a large diversity of animal species, from your large-bodied roaming ungulates like your bison, your pronghorn, and your mule deer. There's also quite a few reptiles in the shortgrass prairies, so rattlesnakes, of course, and what I didn't expect to see so many of, but in this middle of this dry grassland, you also have quite a few turtles as well. You also have quite a few rodents, so your small rodents and your prairie dogs, your lagomorphs, such as your black-eared jackrabbits, And so for my birders in the room too, there are over 300 migratory bird species and quite a few non-migratory bird species. So your burrowing owl is pretty common. And Brad, I'm going to pick on you. Do you know what hawk this is right here? Put you on the spot. You got it. I was just checking to make sure I actually knew it correctly. Yeah, so your Ferret hawk. And then there's quite a few carnivore species as well. So you have your badgers and your coyotes and your swift fox and your black-footed ferret here in the background. And so tonight I'm going to focus primarily on black-footed ferrets and swift fox. So black-footed ferrets are a little bit more well-known, but if you're like me, I didn't really know what a swift fox was until I had the opportunity to study them. So I thought I would first go into the ecology a little bit of these two species. So swift fox originally inhabited the shortgrass prairie region from Canada all the way to Mexico. And this red and yellow color here together shows you the historic range. And this yellow color that you see shows where they're located today. So as you can see, the range has been constricted quite a bit. And to compare that with black-footed ferrets. So the black-footed ferrets are basically wherever you find their prey species, which is prairie dogs. So not only the Great Plains, but these semi-arid desert areas of the West. And the red shows where they've become extinct, and these tiny purple dots here show where they are currently existing today. So a little bit more about the status of swift fox. They're historically widespread and abundant, but a widespread decline began in the late 1800s, early 1900s, and this is due for a myriad of reasons. The big ones were uncontrolled harvest of pelts in the 19th century. You had your prairie conversion to agriculture. We initiated rodent control programs, which is one of their prey sources. We also had predation by domestic dogs. And so as a result, they are a species of concern across most of their range today. And they currently only occupy about 42% of their historic home range. They were once extirpated from Kansas by the 1940s, and they since have made a little bit of a comeback. They were also extirpated in Montana, North Dakota, Nebraska, and Oklahoma. They persist today in these four states, but in states like Nebraska and North Dakota, they are considered state endangered. They were also went extinct from Canada. The last one I saw was in 1928, and extirpation was officially declared in the 70s. And once they were declared extinct in Canada, they began these reintroduction programs. So they are on the Canada's endangered species list. They were also a candidate on the endangered species list here in America, but it didn't pass. And so again, they are isolated in these most southern and western home historic ranges. And so my clicker doesn't like to work here, maybe I sit a little bit closer. So a little bit about black-footed ferret status and management. They were extirpated across almost the entirety of its range, and this was related to the loss of prairie dog colonies. As Eric has mentioned, almost all of the original prairie dog colonies in the Great Plains region have been extirpated. And they're also highly susceptible to disease, so things like sylvatic plague and canine distemper have really caused the population to crash. And so now today there are no known completely and truly wild populations left. They believe that the species was extinct for a little while. In 1981, they rediscovered this ancestral population in Meeteetse, Wyoming. However, in 1985, canine distemper came through, and that population went extinct as well. However, before it went extinct, they were able to capture some of them, and they began a captive breeding facility. So most of the success today is due to those captive breeding activities. However, successes have been tempered by this 40% reduction in population from the years 2008 to 2015. And so now there have been about 30 reintroduction sites, and they're located here on this map. And there's estimated to be about 300 individuals left in the wild. And there, of these 30, only 4 of these populations are considered to be self-sustaining. The rest have all been supplemented each year by reintroductions. So they're reintroducing black-footed ferrets to these other 20-odd sites each year to help the population persist. And so there are 4 populations of limited success. There's quite a few that just haven't done well. So there have been 6 reintroduction sites in the United States that have failed, and there have been 2 introduction sites, 1 each in Canada and Mexico, that have also failed as well. And as a result, you can imagine their populations have also been incredibly fragmented. So what does a swift fox look like? Eric gave us a little bit of a preview about it. They are incredibly small bodied, so they are between 2 and 4 kilograms. The largest one I have handled has been 7 pounds. So if you have a house cat at home, chances are likely that it is going to be larger than a swift fox. And males are just slightly bigger than females. They have this characteristic long black tip tail, and this tail makes up about 52% of its total body length. So it has this very long tail. It also has large ears. So something I should have mentioned in an earlier slide is that swift fox are very closely related to kit fox. And my PhD advisor studied kit foxes, so now him and I both accidentally confuse kit and swift when we talk to each other. So if I say kit fox, I'm really talking about swift foxes. But I did want to bring kit foxes up because they do look very similar to each other. And there was some debate in the scientific community if there was enough dissimilarities to warrant 2 separate species, or if they should be the same, considered the same one species. And what the general agreement today is that because kit fox persists in these areas west of the Rocky Mountains, there is enough geographic isolation and enough genetic diversity to consider these 2 different species. But if you and I were to look at a picture of a kit and swift fox, it's incredibly hard to tell the difference between the 2. And one of the ways you can tell the difference between the 2 is by their ears. So kit foxes have slightly larger ears that are more closer together on the top of their head. So swift fox, their ears are a little bit smaller and they're more widely spaced. And they have these characteristic black patches on their snout. Their pelage or their fur varies in coloration. So in the summer months, they're going to be this more reddish color that we see on this slide here. In wintertime, they tend to be a little bit more gray. They also have lighter colored throats, bodies, and just the general underside as well. Okay, and so swift fox have relatively long legs compared to their body size, and this is an adaptation for running. So true to their name, swift fox are quite fast. And so they've been recorded running up to speeds of 25 to 35 miles over short distances. So they're not endurance runners, they're sprinters. Now, black-footed ferrets, on the other hand, they are also small, between 0.65 and 1.25 kilograms. They also have these long, thin bodies with short legs, though. And this is an adaptation for chasing prairie dogs through prairie dog burrows. They have small eyes and pretty small ears. They have this characteristic black mask around their eyes. And so a little bit more about these 2 species. Swift fox are primarily nocturnal. What's also interesting about these guys, and it's not very common in the mammal world, is they are monogamous. So they live together. They form these they form these long-term bonds with a mate. Occasionally they may live in trios, so you might see one male and 2 females, but typically it's just 1 female and 1 male. These guys are dietary generalists, so they consume a wide variety of prey species. And where they are found is often tied to available den sites. And I'll talk a little bit more about this in a few slides. Black-hooded ferrets, they're also nocturnal. However, these animals are solitary, so they live alone in these prairie dog burrows, and they only get together really when it comes time to mating. They're obligate prairie dog specialists, so they depend on prairie dogs for both food and shelter, and this relationship is thought to have begun about 100,000 years ago as black-footed ferrets moved into the continent of North America. So these are the only native North American ferret species. And so from fossil records, we can look back and we can see 100,000 years ago, prairie dogs, black-hooded ferrets were only consuming prairie dogs about 50% of the time. So this dependence on them has been increasing over the millennia. And of course, their habitat, suitable habitat, is tied to prairie dog burrow density. The swift fox, they live in dens year-round. They use them for a few different reasons. One, to mitigate these harsh environmental conditions. So summer in the Great Plains, it can average well over 100 degrees for weeks on time. They also use them to escape from predators, and they use them to rear young. So you will find multiple dens within a swift fox home range. And dens also have multiple entrances to them as well. And of course, black-hooded ferrets are only found in prairie dog burrows. But swift fox can also modify prairie dog burrows. If they're doing this, they make sure to dig it out just large enough for their body size, because they don't want coyotes or badgers to be getting into these dens. They are capable of digging their own too. And so they're typically located in these heavily grazed areas and pastures, and are also typically found on the top of hills. And the reason for that is they like to be able to scan for threats. So if you're high up on a hillside, you can increase your scanning distance. And also if the vegetation is around you, your view is not going to be obstructed by it. And how well the soil crumbles, the ability to dig out a den, is an important factor for swift fox. Okay, so I mentioned earlier that swift fox are dietary generalists. So they are also very opportunistic, and they eat a wide variety of food things. If they can put it in their mouth and it's edible, they'll eat it. So they're eating small mammals, they're eating invertebrates, they're eating reptiles, they're eating carrion, plants and vegetation they're eating, and birds as well. And so this information, or you can see in parentheses these various percentages. So these come from a couple different studies in different portions of the home range, one from South Dakota and another from Texas. So depending on their location, they may be consuming more or less of each prey item or prey category according to where they're located. And like I mentioned earlier, black-footed ferrets are prairie dog specialists. So over 90% of their diet is going to be prairie dogs. However, they can eat other prey items, but it's very rare. So less than 10%, they may be eating small rodents and occasionally lagomorphs, so your rabbits. So for swift fox, they are pretty social creatures. Their home ranges will often overlap with each other, and the more closely related they are to each other, the more willingness they have for sharing home ranges or overlapping home ranges. And neighbors will occasionally share dens together. So you might find 2 different foxes with 2 different home ranges that are near each other or overlapping each other. They might decide for 1 or 2 nights that they're going to bunk up together. So these guys breed in the winter. They typically give birth to litters of 1 to 5 in the spring, or 2 to 6, excuse me, in the spring. All of the litters I saw this summer, 4, for whatever reason, they just like the number 4. So from 2 to 6, And juveniles will disperse in the fall after they've reached adult size. Now, juvenile male swift foxes are capable of reproducing and breeding the very first year they disperse, and females will typically wait until the following season. So, black-footed ferrets, male home ranges will often overlap with several female home ranges. However, you never see male-to-male overlapping or female-to-female overlapping. When it does overlap, it's most likely because prairie dog burrow density is high. And overlap, there's more overlap when prairie dog burrow densities are high as well. So, I'm sorry, home range, I just said the same thing twice. Home ranges decrease when prairie dog burrow density is higher because they have more food, and then overlap increases when prairie dog burrow density increases. So these black-footed ferrets, they breed in the springtime. These are the ones that breed in litters of 1 to 5. Juveniles will disperse in fall after reaching adult size, and for both swift fox and black-footed ferrets, the males will disperse further than females. And as a result, you see a lot more juvenile male mortality than you see juvenile female mortality because they're crossing these longer distances. And both of them will, male and female black-footed ferrets, breed after 1 year of range. Now, swift fox, their primary cause of mortality is predation by coyotes. And so this term here, interguild predation, is a term we use to explain how larger bodied superior competitors, when they come across a smaller bodied competitor, they'll typically kill it and sometimes consume it. So this is what's happening often when coyotes and foxes of all species interact. And other predators of swift fox include badgers and raptors. And so black-footed ferrets here, their primary cause of death is typically disease-related, so bubonic plague wipes out a prairie dog colony, and because now they have no food, the black-footed ferret ends up dying, or from other introduced domestic diseases associated with domestic animals, so canine distemper too. However, non-disease related causes of death for black-footed ferrets is often also due to coyotes, badgers, and other raptors as well. However, interspecific interactions with there's like a delay on my timer, so I keep hitting it twice, thinking it doesn't work and then it goes. So interspecific interactions between black-footed ferrets and swift foxes is relatively unknown. And so this is pretty much the bulk of my research, is I'm trying to get at how these two are interacting. So my study site is located in rural western Kansas in Logan County, which is highlighted in this plaque here. And it is located on approximately 6,000 acres of prairie dog colonies. And in 2007, it was the site of black-footed ferret release. Now, what is unique about this study site is that its primary land use is cattle ranching. So this is a ranch. And it's very unique to find ranchers in the West who are willing to allow prairie dog colonies to persist on their land. It is also incredibly rare for a livestock rancher to say, yes, please introduce an endangered species onto my property. So for this reason, we have this novel opportunity to explore how conservation can be balanced with these economic interests and also private interests as well. So this study site is entirely privately owned. It is the only black-footed ferret release site that is on private property. So again, just exploring this relationship, how we can balance interest between private landowners and conservation efforts. And so this population of black-footed ferrets at the study site, it began in 2007, and initially it did really well. The very first year it was introduced, they were finding black-footed ferrets reproducing and having successful litters of pups. However, between the year 2011 and 2050, the population, which was estimated at 80 individuals, dropped to just 13 individuals. And we're trying to figure out what happened here. And so the managers, the black-footed managers on this site ruled out disease. There were no instances of canine distemper. Sylvatic plague has not been documented in this county since 1949. So it's not disease related. Prairie dog burrow densities, which is what we use to classify black-footed habitat, suitable habitat, has also remained stable during this time. But the one thing that the managers, so the computer just went to sleep. The one thing that they have noticed when they are working on black-footed ferrets is that whenever they're out, they always see swift fox. About 76% of the time they're doing black-footed ferret surveys, they're seeing swift fox. And not only are they seeing swift fox out on the landscape, but they've been observed going up to a known, where managers know there's a black-footed ferret in that den site, and just sitting and just staring and waiting at it, like come out. So there is some of this observational data that seems to suggest that there is some type of relationship between black-footed ferrets and swift fox. And so primarily, I'm looking at what swift fox is doing. So I'm not spending a whole lot of time on the black-footed ferret side. I'm looking at swift fox. So the first thing I did was we overlaid our study site with these 4-hectare grid cells. So each little square you see on the screen here represents 4 acres. And then I stratified the study site by prairie dog burrow density. So how are swift fox using these prairie dog colonies? So I have 4 categories. So there's no prairie dogs, there is a low density, what I call a moderate or medium density, and a high density. And so black-footed ferret literature always says black-footed ferrets like high, they select for this high prairie dog burrow density. But none of this literature goes on to define what high is. So I had to infer this on my own, and the way I did this was I took a look at a map of known ferret locations. So where are ferrets hanging out on this study site? And from that, and knowing that they select for higher habitats, I came up with this map. And so my low category is between 1 and 50 burrows per hectare, which is indicated in this greenish color. This light blue color is 50 to 100 burrows per hectare. That's my moderate category. And then the high density of prairie dog burrows is anything greater than 100 burrows per hectare. And so at 120 of these locations, I placed a camera trap out on the landscape, and these red dots indicate where I placed a camera. And so I tried to make it even, and so 30 cameras were set in each stratum. And so the reason why I did that is, you could read that and probably were reading it while I was talking, but I was interested in how they're using these colonies and how their use relates to these environmental conditions and habitat variables. And part of that is how are coyotes, this superior competitor, influencing how swift fox might behave in the landscape as well. So I mentioned I put out 120 cameras. I ended up with 116 sites. I did have 4 malfunctions. From that 12 weeks that the cameras were out, 3 weeks at each site, I collected nearly 150,000 images. Yes. Yes. And I looked through almost all of them by myself. So when there was prairie dog burrows, I tried to position the camera in front of the prairie dog burrow, right? Because as you can see from these photos, all kinds of animals use prairie dog colonies, and if you are a carnivore, you go where the prey is, and oftentimes that's prairie dog colonies. And so you can see some of the species I caught. I detected 22 on camera, and of that 22, I only collected 226 carnivores. but that is relatively common. The mass majority of my images were either from prairie dogs or from cattle. So there's a lot of just clicking through prairie dog, prairie dog, prairie dog, or cattle, 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 which are really interested in cameras when they see it. So yeah, a lot of time spent looking at cows and prairie dogs. But you can see some of the images I caught. So in the bottom, don't know how to use my clicker. The bottom left here, this is a coyote at a prairie dog burrow den. Here is the one and only black-footed ferret I caught on camera, which I thought was pretty cool. Here is a prairie dog having a standoff from a rattlesnake. So I even detected rattlesnakes on camera. And they played a large role in my field experience in western Kansas, more than I would have liked. Here's a swift fox up here at a prairie dog burrow, and what's really interesting, it's really hard to see on camera, but it has a prairie dog in its mouth. So we do know, we have evidence here that they certainly are eating prairie dogs. And these two images I added because I thought they were really interesting, again, carnivore species. Both of these photos, it doesn't look like it, but both of these photos were taken from the same camera site. So I positioned this camera, was in a, no prairie dogs were located here, but I positioned it in the bottom of a creek bed because, as you can see, a lot of animal species will use these natural corridors to facilitate movement. And so we have a bobcat here using this corridor. This is on June 16th, and then we had this heavy period of rain, and this dry creek bed actually filled up with water for a little bit of time. So here's a badger coming down through here and making his way across. And so from that camera trap data, I created this map that kind of shows you where I located what. So this orange colored dot, orange and black colored dot shows swift fox. Your yellow colored dot shows coyote. Your black dot shows where we detected both species, and this grayish colored dot, we didn't detect it. And so I did a short analysis on this. Swift fox were detected at 26 sites, coyotes at 22. I detected both species at 8, and I didn't detect anything at 60 of the sites, so about half the sites I just didn't detect. I didn't detect coyote or swift fox. I shouldn't say I didn't detect anything, I just didn't detect coyotes or swift fox. And from this information, so I put in parentheses here what the stratum type was, and I did a quick analysis, and basically our ability to detect a prairie dog, it doesn't matter where they were. There was no difference in detection between places that didn't have prairie dogs and places that had a high amount of prairie dogs too. And I was talking to Eric before my presentation, and one thing that really stuck out to me is I have this one lone swift fox detection in this bottom half, the southern half of the study site. And I have quite a few coyote detections as well. So there might be some evidence here to suggest that perhaps swift fox are trying to avoid these areas where coyotes are more abundant. And so camera trap data is really interesting because you can get a lot of information from them. So not only are you seeing what species you're collecting, but you have information on time of day and temperature and things like the moon phase as well. And so I extracted out this time data and compared them to each other. So you can see swift fox, they really do follow this this mostly nocturnal pattern. You can see they're more active in these early morning hours, in these late at night hours, and then not so much during the day. Coyote, they're shifted just a little bit, so they're more active from 5, 6, 7, 9, whereas swift fox are more active between 1 and 5. And they're still quite active throughout the entire day, and then again, their activity does start to peak later in the evening. And so another piece of our project was looking at the prey availability for swift fox. So we wanted to compare what prey was available to swift fox on the landscape and what they're actually eating. So a good portion of my my field work was collecting scat. And so we had 24 trapping grids. We did 6 grids within each stratum. And we totaled about 882 trap nights per strata. And now we only trapped during the night, so we closed our we opened our traps an hour before sunset, and then checked them within an hour of sunrise, right? Because swift fox are primarily nocturnal. We're interested in what's available to them at nighttime. So it made for a lot of really late nights and a lot of really early mornings. But it's not field work if you're sleeping. So you can see here's our catch effort for each stratum. Or you can see it's incredibly low, right? So especially in these low areas and these medium areas, we caught half a small mammal in 882 nights on average, or per night, I should say. So pretty low. We then calculated, we did an index of diversity, so Brad here is probably familiar with this. This index we used it in a course that Eric was a instructor for. And so the diversity here, which is this H column, is also incredibly low as well. So it doesn't appear that there's a lot of small mammals anyway on the landscape other than prairie dogs for the swift fox to eat. And so right now we are still working on sifting through all our scat samples, so going through one scat at a time, breaking it apart, looking to see what's in it. So we're still working on that. So trapping small mammals. You don't always get what you want. So I sent this message to one of my advisors one morning. Any tips on how to remove a rattlesnake from a small mammal trap?
Carefully.
Yeah, this is what I got. And I was like, okay, great, thanks. And then actually a minute before he sent that, I sent him another photo and said, update, he's out of the trap, and we're both still alive. And so to his credit, I was in rural western Kansas, so he did send that message, and then another very helpful, here's how I would remove a rattlesnake from the trap. But because I was in western Kansas and cell service is a little bit spotty, I didn't get those text messages until after I probably screamed a little, paced back and forth, contemplated what I was doing in western Kansas before I got to it and got it out of the trap. And this next slide here, I sent another text message to my advisor. Hey, we had some major hail come through last night. And what is not on screen is my advisor texting me back, are you sure that's hail? Doesn't look like hail. And then I sent him this photo. I said, yes, it is hail. So that was my experience with small mammal trapping. I also, and Eric and Sue had this opportunity as well, had the opportunity to trap foxes. So Eric, Sue, and I, and others, we set out these tomahawk traps, and we captured a few foxes. And what's really cool about swift foxes is they don't require any anesthesia to handle them. They're incredibly docile. So this one you see in my lap, I am just scruffing it and holding it. And so it behaves more gently and more docile than probably your house pet. And so after we were drawing blood from it, we were pulling hairs from its rump, and it just sits there on your lap really nicely. After we worked it out, we attached these GPS collars. And so what these collars do, I programmed them to record a GPS location every 4 hours that was offset by 1 hour a day. So over a 4-hour period of time, I can generate, like the camera trap data, this 24-hour activity period for swift fox. And so swift fox, right, they live in dens. When they're underground, the GPS signal can't get to it. And so therefore we know when they're not active and when they are active. And so after you, so what's nice about this is that all the locations are stored right here on the collar, so you don't have to go out and do your traditional telemetry where you're trying to find it from 3 different points and taking an average to kind of get at where that location is. You know exactly where it's located. However, they have this little VHF receiver, so you still do have to track it traditionally like you would with radio telemetry just to find it. Which the title of my slide was Outfox, and I was telling Eric I felt a kinship to the prairie dogs, and I was feeling outfox myself. So in our attempts to find it, we went from the traditional 3-element Yagi antenna. Then we tried a 5-element Yagi antenna, wasn't having much luck, and then we brought out this big boy here. So this is an 11-element Yagi antenna that we mounted to a pallet and put in a truck, and here is my research tech trying in vain to find a swift fox. So we actually didn't end up finding a swift fox with this size antenna either. We had better luck visually seeing one while we were out driving during the day. We're like, oh, hey, there's our fox right there. So once you do find a fox, you can generate this really cool map. So in blue, in this dark color blue here is where one fox was located, and this greenish color here, you can see where the other fox we found was located. And I also superimposed roads on here, and then these blue circles here are artificial water catchments. And I did, this is somewhat of an outdated technique, but for exploratory analysis, I thought it would be okay. But this is called a minimum convex polygon, and basically what it does is it just draws a line around all of the known locations of the swift fox to kind of get at its home range. And so what's interesting here is this fox, right? It's really inhabiting this. These bluer colors are the higher density prairie dog burrow densities. You can see it's really inhabiting these areas, not so much any of these no habitat. Now this other swift fox is not quite as fortunate. So you can see there is quite a movement or use of these no prairie dog sites. But what is interesting is that it's really clustered in still in these high density locations as well. So when you see a lot of clusters together, like right here and right here, you have a pretty good indication that's where its den site is. And the same is kind of up here and here. So they're at least likely denning in these higher quality or higher prairie dog burrow density habitats. And so this next slide I'd like to call things I found more often than foxes, as often, or almost as often as foxes. So rattlesnakes. My advisor again liked to send me helpful tips, like FYI, this is not a fox. Because I was seeing so many rattlesnakes, I was catching them in traps, I was catching them on camera, I was just seeing them out in the all day. And so, don't, I repeat, don't put a collar on this one. Sent him back a message that said, I'm really tempted at this point, I see so many of them. I also found black widow spiders. I also found Tarantula Hawks, and they are considered to have the most painful sting of any stinging creature. And I surprisingly had to do way more convincing for my field tech that no, you don't want to experience this sting, even though you are curious. I'm not really sure why I had to. I had to sit her down and explain to her why that would be a bad idea. Here I am sitting next to a mosasaur fossil. So mosasaurs existed between 125 to 65 million years ago. So I was able to find something that had been dead for 65 million years, almost as often as I found foxes. My advisor kindly or rudely pointed out that I had a 1 in 3 chance, a 1 mosasaur to 3 swift fox chance. I also found 7 road-killed swift fox too, so I found significantly more dead ones than I found alive ones. So I did a few other things while I was out there. So if you remember from kind of the beginning of my presentation, I was telling you how we were interested in looking at how the environmental conditions relate to how swift foxes are using this prairie dog colony. So I took vegetation sampling here, and we did visual obstruction and visual concealment, and they're kind of nuanced, but basically visual obstruction is looking at how well a predator is visually obstructed from view of a potential prey species, whereas concealment kind of gets at how well prey is concealed from a predator. So slightly different metrics. So I took a lot of vegetation sampling. We did that at each of our camera site locations. I also gathered some geographic information layers already available to me. So distance to nearest water source. So again, these blue dots are these artificial water catchments. And this has been shown to be an important space use predictor for canine species in the West. In these dry, arid areas, they are drawn to these water locations. Also, distance to the nearest road and the distance to the prairie dog colony edge. If you'll remember, I said that swift fox tend to be up on top of hills, so we thought slope might be important. And I also mentioned that soil type was an important predictor too. However, my study site, as it turns out, is pretty homogeneous. Of the 120 sites I sampled, 118 of them had the same soil type, so I disregarded soil as a considering factor. And so where am I going from here? So I want to develop detection and occupancy estimates using camera data. So what influences our ability to detect a swift fox or a coyote, and what are these environmental factors that are influencing where swift fox and coyotes are located on the landscape? And from occupancy, you can derive this estimate of abundance of these species. I also want to calculate home ranges using more of a statistical technique that's more robust. And the reason why I want to do this is because then you can relate. So occupancy modeling just gets at, did a species use a site, yes or no? And the next step is to calculate the statistical home range, which can relate probability of use. And so what is that difference between not that just that the site is used, but what's the difference between a lightly used site and a heavily used site? I also want to calculate the activity patterns from the collars and compare that to the information I gained from the cameras. So just an interesting methods comparison here. And then finish up our dietary analysis to see, okay, we know what's available, so what are they actually consuming? And then hopefully from all this, we can identify the potential for swift fox and black-footed ferrets and conflict between them, and how we can make better informed management decisions. So with that, I'd like to acknowledge my graduate committee. Without them, their guidance and support, I wouldn't be here tonight. My field technician for coming out to rural western Kansas with me, about 40 minutes from the closest town. And then also a lot of my supporters and funders too, who made this project possible. And so anyone has any questions, I'd be happy to take those. Yes?
I want to know, how did you end up with going out to Logan County, Kansas?
Yeah, so that's a really interesting question. And so Eric had a former grad student. He also did his undergrad and master's degree at UWSP, and he really has made a name for himself and is very well known in the black-footed ferret realm. So if you hear black-footed ferret, he's there too. And so he was the one who got this project going. He's the one who is in Kansas facilitating the release and also monitoring of black-footed ferrets. And he's the one who's like, hey, I'm seeing a lot of swift fox, so maybe we can try and figure this out together. So that's where that partnership came from. Eric.
Kara, that's a phenomenal decline in the black-footed ferrets.
Yes.
So you were there for how many months? 4 months? 2 months?
Yes.
Yeah. So what do you think's going on there? What do you think caused the ferrets to disappear like that so rapidly?
Well, yeah, it's interesting because it's in line. I mentioned that 40% range-wide decline, population-wide decline across the range. And I can't say what's going on everywhere, but from my initial data and analysis, it seems that swift foxes are using these heavy density or these high density prairie dog colony sites, and they are either outcompeting black-footed ferrets, so we have evidence that they're eating prairie dogs, so perhaps they are eating the prairie dogs, then they're outcompeting black-footed ferrets, perhaps causing black-footed ferrets to also select for these lower quality sites. And then we haven't been able to officially prove it, but we've had just this past winter, within the last couple of months, there are some black-footed ferret managers out on the landscape, and again, they saw a black-footed ferret, and they saw a swift fox from a distance, and then they heard this yelp that sounded like a black-footed ferret, and then they saw this long, thin-bodied creature in the swift fox mouth. So, right, we can't 100% confirm it. It was in the middle of the night, it was dark, but it seems likely that there might be also some of this intrafield predation too, where swift foxes are slightly larger bodied than black-footed ferrets, and it's likely that when they're encountering black-footed ferrets, they are opportunistically killing them as well. Brett.
You had mentioned that it's interesting that these, I assume it's one cattle rancher that allowed the introduction of these black-footed ferrets?
Yes.
Do you know how surrounding ranchers feel about that?
Yeah, yes I do. And so what I forgot to mention, and Eric specifically asked me to mention like 15 minutes before the talk, is that this study site is really unique in relation to its neighbors. So this is a cattle ranching, managed for cattle ranching, but everywhere around it is this mosaic of agriculture, so mostly wheat and sorghum and corn production. And their neighbors despise them. And that might be like using, I might not be giving it enough credit. So I can tell you exactly why there's black-footed ferrets on the landscape now. It's really interesting. So this manager or this cattle operator, he's not necessarily conservation focused, but he came through it organically, right? He recognized that prairie dogs have been on this landscape. He holistically manages and grazes, so hard and fast, rotating them around. So he's already mimicking these natural patterns that the large ranging ungulates like bison used to do. So he's mimicking that, and he recognized that prairie dogs are part of that natural ecosystem, and if it's a natural part of that ecosystem, then it must be good to have them on the landscape, which of course infuriated all of their neighbors. So in rural western Kansas, prairie dogs are considered a weed, and so they poison and kill their weeds. And so the neighbors actually sued and brought this landowner to court to get them to poison and kill their prairie dogs. And the landowners won that case, so the neighbors brought it to appeal. The neighbors won on that case, and then it got sent to the Supreme Court of Kansas. And so now the benefit of these landowners, these cattle ranchers, they had a pretty crafty lawyer. So while they're preparing for the Supreme Court battle, their lawyer said, well, hey, if you introduce black-footed ferrets onto your property, it's an endangered species and they're federally protected. So if you do that, right, the judge is going to have to rule in your favor. And so they did, and that's exactly what happened. And so that's why I am here today. So yeah, this was about 10 years ago, 10, 15 years ago, and relationships are, warming up a little bit, but they're still not well liked in town. So it's pretty rural area, dirt roads, and so if they see two youngish looking women on the landscape. Of course, everyone stops and wants to know what you're doing because you're in the middle of nowhere. So I usually got an earful about what these various neighbors thought of this one landowner. Wasn't typically favorable. So. Yes.
I was curious the logistics of how you did this. Now, this was 2018, right? Or did you do
Yes.
it 2017?
No, 2018. So
Okay,
this last summer.
you said 4 months. I saw June
Yes.
up there, June, July, August, and so.
May.
And May.
Yeah.
Okay, and then how did you sleep? Because you gotta sleep sometime. And you're up all hours of the night?
That's a very good question. You should ask my advisor.
How do you sleep?
Short stretches. So.
A couple hours here, a couple hours there?
Yes, usually, so we trapped at night, we check traps early in the morning. Most of our swift fox, because they're nocturnal, are GPS collars when we're trying to be out in the field trying to track these foxes down occurs overnight. So it made for very late nights, very early mornings, very little sleep in between. But in western Kansas in the summer, it's kind of on the cusp of being the Southwest. So you have a lot of these Southwest desert species. It's very dry, and it gets very hot in the summertime. So usually about 10, and if you've ever been and spent time in the Great Plains, you understand that wind that blows through. There's this precise time of the day where it switches from being enjoyable to feeling like you're under a blow dryer. So at that point of the day, we usually called it quits for the midday hours. So we tried to rest and get a lot of our sleep in during the hot period of the day. So noon to 4 or 5-ish, we tried to get some sleep.
And then the collars that you talked about,
Yes.
how many animals have the collars?
So we have 6 that
6.
have collars. So of course, you always want a large sample size. Each one of these collars costs $1,500. So we're definitely limited by how much money we could drum up. So.
And my last question is,
Yes.
at the end of the 4 months, do you get the collars back?
No, so we don't. Well, the first thing is you have to find the swift foxes. So we actually only found 3 of the 6. And there's some biology that might suggest why we had such a hard time finding them. So first, they live in dens underground, and when they're underground, you can't hear the signal. They're also social, right? They're monogamous. They always have a mate. So they're a dog, right? They're a dog species, right? So we found a lot of their dens, so we knew where they were living at one time. And you see I found one time the scapula of a cattle. So when a cattle dies, they just leave it on the landscape, and it had chew marks, and it was right in front of their den. So they chew things. They like to chew on things. So it's possible that maybe they're chewing on the antenna. And also, if they're killed either by a coyote and it gets brought down into a den, or if they so when the mate of a male swift fox dies, the male will disperse out of the home range. It will go far away. So that could be possible too, as why we're having such a hard time finding them. And we try to have an even ratio of males and females collared, but males, for whatever reason, were a lot more trap happy than females. So the one collared fox that you saw, Eric and Sue trapped it once when they came down in October of 2017, and then we trapped him 2 more times. Free chicken dinner. But we were interested. We wanted to get females too, and so we're like, okay, we know where our male fox is. We know where their den is. We've seen this female. Let's just set all our traps in this ring, around their den to try and catch them. And we caught the male twice, and the female never. So she was a little more shy, and the male was realizing that he would get a free chicken dinner and a safe spot for the night, and maybe some trouble from the missus in the morning, but nothing could explain away. So.
This might be an easy question,
Yes.
but how do you tell the entrance to a den that's a black-footed ferret versus a swift fox versus a prairie dog versus all the other mammals?
Yeah, that's a good question.
How do you tell the
That's a-
entrance apart?
That's a good question. So you wouldn't be able to tell the difference between a black-footed ferret and, say, a prairie dog, because black-footed ferrets just use prairie dog burrows. Swift fox can use prairie dog burrows, but they can also dig their own. So they have this actually characteristic like keyhole type shape to their den. So it's like long and thin. Yeah, and it's small. It's small enough where it excludes coyotes and badgers. So if you see these larger dugout areas, then you're like, okay, that's most likely a badger. Badgers also dig and they kick up a lot of dirt. So that's another good way to tell a badger apart from just like a coyote hole.
Well, Kara, thank you very much for speaking.